Alright, question 12 here. Which lines or segments are parallel? Identify the converse that allows you to say so. So looking at number 12 here, we can kind of observe angles that you would think would be same side interior. So for example, 96 and 79, 96 and 79, you already know that it's not going to equal 180. Because in the ones place, that equals 15 as a sum, or 5 as your end digit, not 0, like 180. So these lines, these lines are not parallel, we can tell already. Because the same side interior angles are not 180 degrees. Let's look at these lines though now. Here's this transversal. We see that this is 101, this is 79. If you add those up, you do get 180 degrees, which means these same side interior angles are supplementary. So we can say A is parallel to B by the converse of same side interior angles. Cool. Oh, this one would be a good fun for you to practice because you'll have to actually go one by one. What about these ones? What about these two? What about these two? What about these two? What about these two? And just go through those. Just make sure you identify like the vertical angles and the supplementary ones, because then you would have an easier time. This should be 180. Wait, what would this be? 192? Is that right? No, way off. 102. So this would be 102, 112. This would be 68, 68. So identify those first, and then go through the lines and see which ones are parallel, and which converse theorem you're going to use. These are pretty easy proofs right here. We're trying to prove that AB is parallel to CD, and they tell us that, it's a bad line, 1 is parallel to 2, and we know 3 is parallel to 4. Or that said parallel, I meant congruent. Okay, so that already sets us up most of the proof. One thing I'm going to have to identify though is angle 2 is congruent to angle 3 by vertical angles theorem. And now I can use the transitive property to say, since angle 1 is congruent to angle 2 is congruent to angle 3, and angle 3 is congruent to 4, by the transitive property, angle 1 is congruent to angle 4. And this helps us because if you look at the hopefully parallel lines in this transversal, you see angle 4 and angle 1. Let me draw that transversal. Angle 4 and angle 1 are alternate interior angles. So we can say that AB and DC, or CD, are parallel. AB and CD are parallel. Remember, if we're proving lines are parallel, we're using the converse. The converse of alternate interior angles theorem. Okay. Wasn't so bad, was it? Okay, so let's look at this one real quick. We know A and B are parallel. Here's our transversal. And then we have angles 1, 2, and 3, which are expressed as such. X plus 3y 2x plus 30, and 5y plus 20. So what we can do is, since we know these lines are parallel, we know that the corresponding angles, such as 1 and 3, are congruent. In other words, the measure of angle 1 is equal to the measure of angle 3. So the measure of angle 1 is x plus 3y. We know this is equal to the measure of angle 3, which is 5y plus 20. And then let's just do 1 and 2. We could do 3 and 2. 1 and 2 form a linear pair, so they're supplementary. 2 and 3 form a same side interior angles, so we know they're supplementary. You can choose whichever one you want. I think I'll do 1 and 2. So since I know, and I'll just write this so we can see clearly, the measure of angle 1 plus the measure of angle 2 equals 180. By the linear pair postulate, I know that x plus 3y plus the measure of angle 2 is 2x plus 30 equals 180. Did I write that okay? Yeah, I wrote that all good. So now I have a system of equations. And again, we can solve by graphing, we can solve by elimination or substitution. I think the way that I will do it is, first I'll simplify. I think this first equation here would look better if we kept the x on one side but subtracted 3y from both sides. 5y minus 3y is 2y. So just kind of X this out so we don't look at it any longer. And then we'll simplify this one by combining like terms. 3y plus 3x plus 30 equals 180. We'll subtract both sides by 30. Oh, this should be 150. And I'm going to take a little shortcut here. Since I know each of these terms in this equation, this term, and this term, all are divisible by 3, I'll just divide by 3. 150 divided by 3 is 50. Okay, so I have these two equations. Much simpler than the original ones. What I can do is substitute. I'm going to substitute. So where we have x is equal to 2y plus 20 is what I'll replace in this equation down here. So I'm going to rewrite it y plus, and I'm going to put in what y is equal to, or what x is equal to. 2y plus 20 is equal to 50. Combine like terms and subtract both sides by 20 and find out that y equals 10. Cool, since y equals 10, I can plug it back in here to find x. Cool, so I have those two solutions. In which case we would write x comma y as our solution. So this is what your solution looks like.